next example, we're looking at an improper integral that has infinities both on the lower bound and upper bound, so negative infinity to infinity. E to the 4x dx upstairs, and 1 plus e to the 8x in the denominator. So this one we're closest to something resembling a tangent. E to the 4x dx upstairs, 1 is the same as 1 squared, e to the 8x is e to the 4x squared. So we're going to let e to the 4x equal 1 tangent theta. So 4e to the 4x dx is worth secant squared theta d theta. Okay, so seeing what we have and what we're missing, we've got our e to the 4x dx, we're missing our 4. So we multiply by 1. 4 inside, 1/4 outside. And we can carry that over to the next step as well, make it a little easier to follow. So we have 1/4 integral from negative infinity to infinity. 4e to the 4x dx is secant squared theta d theta. And in the denominator, we have our 1, and e to the 4x is 1 times tangent theta, so e to the 4x squared is tangent squared theta. So remembering that secant squared minus tangent squared is 1. 1 plus tangent squared is secant squared, so we have 1/4 integral from negative infinity to infinity of secant squared theta over secant squared theta times d theta. Secant squareds drop, so 1/4 integral negative infinity to infinity d theta. So that is 1/4 theta evaluated from negative infinity to infinity. Let's get our original back in there. So we said in our substitution that e to the 4x was tan theta. So theta is the arctan of e to the 4x. So this is then 1/4 arctangent of e to the 4x, evaluated from negative infinity to infinity. So we can break this up using our limits. So 1/4 arctangent e to the 4x from negative infinity to, we'll break it up at 0, plus 1/4 arctangent e to the 4x from 0 to infinity. So the first one, we have 1/4 arctangent e to the 0 is 1, minus 1/4 arctangent e to the 4x, e to the 4 times negative infinity, we have e to some large negative power, we're close to 0. We'll clean that up in a moment. 1/4 arctangent e to the 4 times infinity, arctangent of infinity minus 1/4 arctangent e to the 0, which is 1. Okay, so we have 1/4 arctangent of 1. So the output is 1, so sine and cosine are the same. That's at a 45-degree angle, so that is pi over 4. If the arctangent is 0, that means, remember, tangent is sine over cosine, so that means sine is 0. Sine is 0 at 0. 0 times negative 1/4 is 0. Arctangent of infinity, this means the denominator of sine over cosine is going to 0. Cosine is 0 at pi over 2. And arctangent of 1 is our pi over 4 again. So our pi over 16s will drop. So we end up at pi over 8. All right. Let's play with another one. So some more discontinuities. So this one will look integral from 0 to 16 of 1 over 4th root of x times dx. So notice here one of our bounds does give us a discontinuity. The function is not defined at 0. It's referred to as an infinite discontinuity. So we basically see what we can do with it. We'll make this x to the negative 1/4 times dx. And we'll approach 0 from the right. So our antiderivative, x to the 3/4, so we'll need a 4/3 there. We'll evaluate from a to 16, and we'll take the limit as a approaches 0 from the right. So we have 4/3, 16 to the 3/4 power. 4th root of 16 is 2. 2 cubed is 8. If we let a approach 0, 4th root of 0 is 0. 0 cubed is 0. 0 times 4/3 is still 0. So 32/3 is our limit, so that is our integral with this infinite discontinuity. Our next one, we'll play with the integral from negative 5 to 5 of dx over x to the 6. So this one, instead of one of the endpoints being the discontinuity is in the middle of this interval. If x is 0, you can see we're dropping our denominator to a 0. So we just split it. So we'll look at the integral from negative 5 to 0, x to the negative 6 dx, and add that to the integral from 0 to 5 of x to the negative 6 times dx. So then we integrate. So x to the negative 6 is now x to the negative 5, so I'll need a negative 1/5 there. Evaluating that between negative 5 and 0. And do the same thing, 0 to 5. So we have -1 over 5 times 0 to the 5th. So this still diverges. So this one still does not approach a constant. Okay, and then our last one from the section, integral from 0 to infinity of dx over root x by x plus 1. So in this one, what we're going to do is multiply top and bottom by, we're going to move the root x to the top. So we'll try integral from 0 to infinity, make this x to the -1/2 up top, x plus 1 on the bottom, and hang on to our dx. Now, with the plus sign here, this is closest to a u squared plus a squared situation. So we'll sort of complete the illusion here. X is the same as x to the half squared, power to a power you multiply. There's the implied exponent of 1. And 1 and 1 squared are the same. So we're going to let x to the 1/2 equal tangent theta. So 1/2 x to the -1/2 times dx is worth secant squared theta d theta. Okay, so we have our x to the -1/2, we have our dx, we don't have our 1/2 in here. So we'll multiply by 1/2 in here, which means a 2 out there. So we have 2 integral from, we'll just put in generic a to b for the moment and clean up later. Half x to the -1/2 dx is secant squared theta times d theta. Downstairs, x to the 1/2 squared is tangent squared. And we have our plus 1. So remembering that secant squared minus tangent squared is 1. Tangent squared plus 1 is secant squared. So we have 2 integral from a to b of secant squared theta d theta over secant squared theta. So that is 2 integral from a to b of d theta. So this is 2 theta from a to b. And then we'll put our original back in. So tangent theta is x to the half. So theta is arctan of square root of x. And we're evaluating from 0 to infinity. So we have 2 arctangent of square root of infinity still approaches infinity. Minus 2 arctangent of square root of 0 is still 0. Arctangent is going to infinity, so that means the denominator is approaching 0, so cosine is going to 0. That happens at pi over 2. So we have 2 pi over 2. Arctangent being 0, so that means sine was 0. Sine is 0 at 0. So this one we land at just a nice, neat, pretty pi. So in section 8.8, I would recommend 1 to 53 on the odds. If you have any questions, please get in touch with me. Otherwise, stay safe out there, and I'll see you next time.